Strikeover, also known as flashover, is an electrical breakdown of the insulation between two conductive parts in a circuit resulting in an arc. This arc can cause significant damage to equipment, pose a serious safety hazard, and disrupt operations. Understanding the causes, prevention, and consequences of strikeover is crucial for ensuring electrical safety and reliability. Firstly, understanding the concept of dielectric strength is important. Dielectric strength refers to the maximum electric field that a material can withstand before it breaks down and becomes conductive. When the electric field exceeds the dielectric strength of the insulation, strikeover occurs. This breakdown can be caused by several factors, including voltage surges, contamination, insulation degradation, and environmental conditions. Voltage surges are transient overvoltages that can occur due to lightning strikes, switching operations, or equipment failures. These surges can significantly increase the voltage across insulation, exceeding its dielectric strength and causing strikeover. Contamination, such as dust, dirt, moisture, or chemicals, can accumulate on insulation surfaces, reducing the dielectric strength and providing a conductive path for strikeover. Insulation degradation occurs over time due to aging, thermal stress, mechanical stress, or exposure to environmental factors. This degradation reduces the insulation's ability to withstand voltage stress, making it more susceptible to strikeover. Environmental conditions such as high humidity, temperature extremes, and corrosive atmospheres can also contribute to insulation degradation and increase the risk of strikeover. Secondly, preventing strikeover involves implementing a comprehensive approach that addresses the underlying causes. This includes proper insulation selection, surge protection, regular maintenance, and environmental control. Selecting the appropriate insulation material for the specific application is essential. The insulation should have a dielectric strength that is sufficient to withstand the maximum operating voltage and any potential voltage surges. Surge protection devices, such as surge arresters and transient voltage surge suppressors, should be installed to protect equipment from voltage surges. These devices divert surge current away from sensitive equipment, preventing overvoltage stress on insulation. Regular maintenance is critical for identifying and addressing potential insulation problems before they lead to strikeover. This includes visual inspections, insulation resistance testing, and partial discharge testing. Visual inspections can identify signs of contamination, degradation, or physical damage. Insulation resistance testing, such as megameter testing, measures the resistance of insulation to detect weaknesses or defects. Partial discharge testing detects localized electrical discharges that can occur within insulation, indicating early stages of degradation. Environmental control measures can help to minimize the impact of environmental conditions on insulation. This includes maintaining proper ventilation, controlling humidity, and protecting equipment from corrosive atmospheres. Regularly cleaning equipment and insulation surfaces to remove dust, dirt, and other contaminants is very important. Applying protective coatings to insulation can help to prevent moisture absorption and corrosion. Thirdly, proper grounding is essential for electrical safety and strikeover prevention. Grounding provides a low impedance path for fault current to flow back to the source, allowing protective devices to quickly trip and clear the fault. This minimizes the duration and magnitude of overvoltages, reducing the risk of strikeover. The grounding system should be properly designed, installed, and maintained to ensure its effectiveness. This includes using appropriately sized grounding conductors, making secure connections, and regularly testing the grounding system. When strikeover occurs, it can have significant consequences. The arc that results from strikeover can cause severe damage to equipment, including insulation failure, conductor melting, and component damage. This damage can lead to costly repairs, downtime, and lost production. Strikeover also poses a serious safety hazard to personnel. The arc can cause burns, electric shock, and even death. Additionally, strikeover can create an arc flash, which is a dangerous release of energy that can cause severe injuries and property damage. Fourthly, mitigating the effects of strikeover requires a multifaceted approach. Firstly, Overcurrent protection devices, such as circuit breakers and fuses, should be properly sized and coordinated to quickly interrupt fault current. Secondly, arc flash protection measures, such as arc flash relays and current limiting devices, can help to reduce the duration and magnitude of arc flashes. Thirdly, personal protective equipment, or PPE, such as arc-rated clothing, gloves, and face shields, should be worn by personnel working on or near energized equipment. This equipment provides protection from the hazards of arc flash and electric shock. Considering specific scenarios, in high-voltage substations, strikeover can occur across insulators supporting busbars or transformers. This can be caused by voltage surges, contamination, or insulation degradation. To prevent strikeover, substations should be equipped with surge arresters, regularly inspected and cleaned, and have their insulation tested periodically. In industrial facilities, strikeover can occur in motor control centers or switchgear. This can be caused by voltage surges, contamination, or equipment failure. Industrial facilities should implement a comprehensive maintenance program that includes regular inspection, testing, and cleaning of electrical equipment. In commercial buildings, strikeover can occur in electrical panels or distribution boards. This can be caused by voltage surges, loose connections, or insulation damage. Commercial buildings should have their electrical systems inspected regularly by qualified electricians and ensure that all electrical equipment is properly maintained. In residential settings, while less common, strikeover can still occur due to faulty wiring, damaged appliances, or lightning strikes. Homeowners should have their electrical systems inspected periodically and take precautions to protect their homes from lightning strikes. To delve deeper into prevention methods, consider insulation coordination. Insulation coordination is the process of selecting and coordinating the insulation levels of different components in an electrical system to ensure that the insulation withstands the expected voltage stresses. This involves considering the maximum operating voltage, transient overvoltages, and environmental conditions. Proper insulation coordination helps to prevent strikeover by ensuring that the insulation is adequate for the specific application. Partial discharge monitoring is a valuable tool for detecting insulation degradation before it leads to strikeover. Partial discharges are localized electrical discharges that occur within insulation due to defects or weaknesses. Monitoring partial discharges can provide early warning of insulation problems, allowing for timely repairs or replacements. There are various methods for partial discharge monitoring, including online monitoring, offline monitoring, and portable detectors. Infrared thermography is another useful technique for identifying potential insulation problems. Infrared thermography uses an infrared camera to detect temperature differences on equipment surfaces. Hotspots can indicate insulation weaknesses, loose connections, or other problems that can lead to strikeover. Regular infrared thermography inspections can help to identify and address these problems before they cause equipment failure. Furthermore, consider the impact of altitude. The dielectric strength of air decreases with increasing altitude. This means that equipment operating at higher altitudes is more susceptible to strikeover than equipment operating at sea level. When selecting equipment for high-altitude applications, it is important to consider the altitude deterring factors specified by the manufacturer. These deterring factors account for the reduced dielectric strength of air at higher altitudes. Also consider the impact of temperature. The dielectric strength of some insulation materials decreases with increasing temperature. This means that equipment operating at high temperatures is more susceptible to strikeover than equipment operating at lower temperatures. When selecting equipment for high-temperature applications, it is important to consider the temperature deterring factors specified by the manufacturer. These deterring factors account for the reduced dielectric strength of insulation at higher temperatures. Also remember about the effects of humidity. High humidity can significantly reduce the dielectric strength of insulation. Moisture can accumulate on insulation surfaces, providing a conductive path for strikeover. In humid environments, it is important to use insulation materials that are resistant to moisture absorption. Also, consider using dehumidifiers or other methods to control humidity levels. Additionally, consider the effects of vibration. Vibration can cause mechanical stress on insulation, leading to degradation and increasing the risk of strikeover. In applications where vibration is present, it is important to use insulation materials that are resistant to vibration and to properly support and secure electrical equipment. Furthermore, consider the effects of chemical exposure. Exposure to certain chemicals can degrade insulation materials, reducing the dielectric strength and increasing the risk of strikeover. In environments where chemical exposure is possible, it is important to use insulation materials that are resistant to the specific chemicals present. Also, protect electrical equipment from chemical exposure by using appropriate enclosures and seals. Regularly training personnel on electrical safety procedures is crucial for preventing strikeover. Personnel should be trained to recognize potential hazards, use personal protective equipment, and follow safe work practices. Training should also cover the proper use of test equipment and the importance of regular maintenance. Performing regular risk assessments to identify potential strikeover hazards is also important. Risk assessments should consider the specific operating conditions, equipment, and personnel involved. The results of the risk assessment should be used to develop and implement appropriate safety measures. Implementing a comprehensive electrical safety program is essential for preventing strikeover and ensuring the safety of personnel and equipment. This program should include written procedures, training, regular inspections, and risk assessments. The program should be reviewed and updated regularly to reflect changes in operating conditions, equipment, or regulations. To summarize, strikeover is a serious electrical hazard that can have significant consequences. Understanding the causes, prevention, and mitigation of strikeover is crucial for ensuring electrical safety and reliability. By implementing a comprehensive approach that includes proper insulation selection, surge protection, regular maintenance, environmental control, and grounding, the risk of strikeover can be significantly reduced.